So listen, there seems to be this idea in BIM that making something fully parametric and 3D takes a long time and should cost a lot more, and so it's easier to do it in 2D, so let's get it over and done with. That is not true, and I believe that making things fully in 3D is more the responsibility of the engineer, because it's so much easier to actually do it in 3D fully parametric. Let's just say I have this plate here and I want to increase the size of the bolts, increase the spacings and the edge gap or the size of the plate, whatever, anything I want to change. I want to be able to just select it and do it in the clicks of a few buttons within this project. I can't do it with this one in particular, but I'll show you how to do that now quickly. Like, this video will not take that long. Let me get my timing up here. We should be able to do it in under 5 minutes to create the whole plate fully parametrically. So it's been 1 minute now, so by minute 6 we should be done. So let's just do it for this project, and I'm just going to stick it on this face here, not going to make it exactly the same because I've only just opened this and I don't have my view set up to align it properly. Well, I've got these here. Okay, so it's been another 20 seconds, so by 6 minutes 20 we should have it. So file, new, family. No, I'm not going to do that. I have my own custom template, which I'll show you how to make in another video, but this is what you need to be doing, making these simple templates that everyone can use. They're user friendly and people will want to use them, and they won't realize, but they'll learn a lot about making families just by using a template where everything has already been set up. So I've already got all my parameters in and all my reference planes. All I need to do is put my extrusion down, select lines, lock, 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 TR for type TR for trim. Boom. We'll go to the front and remember to do this step. Lock it to that reference plane, which is where my plate is. My plate face is going to be. And select it, and I've already put in a material parameter, so I tell this to follow the parameter. Now I bring in a bolt, which I've preloaded in, place on work plane there, and edit the work plane plate face. Select it, type AR for array, boom, select it, select that, and say, well, you know what, I'm going to undo that. I'm going to select the bolt and just change this parameter to the bolt length, which I actually forgot to set up now. Oh no, I did. Yeah, the bolt length is going to be the thickness plus the thickness of the second plate, so whatever plate this attaches to. And I'm actually going to copy that one. I like to keep these separate. Select this, type AR for array. Same with this one. Now, apologies. I need to add the size label. Yeah, there you go. Array. Boom. Oh. Array each one. Select this, select that. Add the number of bolts to the label. Yeah, I did add the size label to that one, so this should be good. Now I'll align it to this reference plane, which is the edge gap. Oh, I've got multiple align on, so there you go. That is us done, I believe. So if I go to 3D view, set this to realistic. Yep. Let's just actually put it on wireframe so you can see where the bolts will end. Now, let's just say I want to change a few things parametrically. Let's just say I want a wider width, 600 by let's say 500, thickness So that's the plate, this plate that we can see, that thickness, let's just say is 75 mil, and the second plate, move that one up. Well, I'll keep edge gap up here after thickness. The second plate will, no, sorry. The second plate will be 75, and then the edge gap, which is the gap from the edge to here and from there to there, which you can keep separate in the separate x and y coordinates if you really want to. We'll call that 75, and we'll hit apply, and everything adapts accordingly. Boom. And let's just say I want to increase the number of bolts, or change the bolt size, increase the number of bolts, and let's just say I want 600 now. Boom. Done. And of course, if we look at realistic mode, this has the plate material implemented into it. And we're at 6 minutes. There you go. Now I'll load it into the project. Building is the one. And I can place it on any face because it's a face-based template. And let's just make it stand out a little. There you go. And I can move it around, manipulate it, or edit it. Edit the sizing again. Let's just say 700 by 750 by, I don't know, 100 thick plate. Edge gap 50. Bolt size, we decide M20, and we only want 3. Okay, well, M20 doesn't look realistic. Let's put M40. There you go. And so the second plate would be the thickness of this I-beam. So I'm not going to work that out. You can do that for yourselves on your own project. And it would stay tight to that if you did put that in. I'm trying to think about what else could be said about this, because I had a good point on this one. Yeah, sorry, you can learn to make this bolt parametric in one of the videos in the description below, as well as learn to make a bolt with washers on. You can use your own custom different types of bolts, and you can also learn to make the template file itself in the description below. Done.